continuous. So we have looked at the techniques for trigonometric integrals, the one for cos and what? Sine. And we are done with that when it's even, odd, and others. So welcome to the part 2 under this part. Another section. So now here we are going to look at what if and in fact the same way. Alright. And whether this or this. We know that the reciprocal for tan is called the reciprocal for sec is cos. But here it will, with the identity, since we are using the identities, it will be linking to this. So this is the same as this. Alright, let's look at this. This is the idea. If the power of tan is odd, keep one. Keep one. Keep one factor of what? Sec x tan x. And use this to be equal to this. Alright? So if tan is odd, as we normally say, you push one of it. Alright? So let's say it's for 3. So you keep 1. Then it will be left with tan squared. Then you do the substitution of this. If the power of sec, so we are coming to this part. What if the power of sec is even? Let me link it. In other words, we are saying that if the power of cos is also odd, you keep one factor of, so that one will be one factor of what? Sec cos, cosec cos, and use this. You don't need to be chewing both stuff. Alright? If the power of sec is even, strip off sec and use that. That's what we're going to do. Let's look at an example and you get to understand what I mean very well. So we have the example already on the board. And now watch. Here, what we are saying is that, let me check something, power 5 and power 3. So here both is what? Odd. So all that we are saying is that we are saying if the power of tan is odd, you keep one factor of what? This and this. So watch. So let's look at the example. Here, this is the same as you push one of this, so you get 4. Push one of this, yes, and the sec also, so that you can get it. So here will be sec x raised to the power 2. Then here will be left with sec tan. Sec x tan x ds. Do you know why we are doing that? That is what you need. The why. The why. The why is that here we are going to set our u. Alright? We are going to set our u. And we know that when you set the u, when you differentiate sec, what do you get? Sec tan. That is why we have to get this one here. So that when we come to this part, we know that, very good. We know that this is the same as tan square x raised to the power 2. Here is sec square x. I'm coming. Here is sec x tan x ds. So here, by the identity, we can do the substitution of this here. By the identity, we can get 1 minus sec square x minus 1 all squared. Then here we get sec square x sec x tan x dx. So here you can see we have sec, and all this is where we have the tan in. And the reason is that we want to let u to be equal to sec s. Please here, watch me well. Watch me well. It's not about watching my face. The board. Alright. So here, when you differentiate this, you will get sec s tan s dx. And that is exactly what we see here. That is exactly what we see here. So we can see that the whole of this is the du. And the exact same thing here, we can do the substitution of it, and that is what? U. Alright. So we get here to be u squared minus 1 all squared, u squared, and the whole of this is what? Du. Fantastic. Fantastic. So here what we get here, when you do this, you get u raised to the power 4 minus 2u squared. Alright. Then you square the 1, you get plus 1. Multiplying u squared du. Exactly. Exactly. So that is what we have. Then you multiply these two out. You get u raised to the power 6 minus 2 u raised to the power 4 plus u squared du. So when you integrate this, so the integral is going to be equal to power 7 over 7 minus 2 over 6, 2 over 5, u raised to the power 5 plus 1 over 3 u raised to the power 3 plus c. Then you know that u is equal to sec x. So please, what is difficult about this? We are done now. We are done. We are done. So what's the difficult about this? It's not difficult. Right? You just need to apply your simple algebra and your previous knowledge. Alright, so that is the one for sec and tan. And as I said, in the same idea we used to do the cot and the cosec. Alright. Let's look at another one. Let's look at another example. Now, looking at the next one, the idea here is that if the power of tan s cot, let's pause the video and finish writing it before. Alright, let's look at the case where we are dealing with cot and cosec. So for instance, a question like cot to the power 5x cosec x to the power 5 dx. Alright, what if we have something like this? If the power of cot is off, keep this and use this. So that's the particular identity. If power of cosec is even, you keep that and use this particular identity for this. And when you also, with this one, when you keep, if it is that, use the particular identity of that to that. Very good. So let's look at how we solve the question. Let's solve the question and see how that works. So as we said, we keep this. This cosec cos. And you have to know the reason why we are keeping that. Because when you differentiate cosec, you get cosec cos. Alright. The negative is not the problem here. The concept I'm giving you is that the reason why we are keeping the cosec cos there is that we will definitely set u to be equal to cosec. And when you differentiate cosec, you get cosec. I know it's negative cosec cos. So here you get cosec to the power 4 cos to the power 4s. Then you get cosec s cos s ds. So having this, we can write this as, alright, so we can write this one that we have here, we can write this as, we know that we have to go and do the Pythagorean identity, the substitution of the Pythagorean identity of cos squared. Alright, so make sure that let's repeat this. So this is the same as cos square s to the power 2 cosec s cos s ds. Now, with the identity, we are going to get cosec to the power 4s. Alright? Then we know that cos square is cosec square s minus 1 all square times cosec s cos s dx. And now, looking at it critically, we can let u to be equal to cosec s. And when you differentiate cosec s, you are going to get du to be equal to cosec s cos s ds. Don't forget here is negative. But when you negate both sides, you get this. So negative du is equal to this. And this is exactly what is here. So by substitution, u raised to the power 4 will multiply u square minus 1 all square times the whole of this is negative du. So we get negative integral of u raised to the power 6 minus u raised to the power 4. Oh, sorry. So u raised to the power 4, what type of multiplier? What I did? So here we get u raised to the power 4 minus 2u squared plus 1 du. Alright. So having that, then we can get the integral of u raised to the power 8 minus 2u raised to the power 6 plus u raised to the power 4 du. Now, even if the negative affects the inside, we are going to, or you can choose to maintain the negative there and integrate each term. So by integration, you get u raised to the power 9 over 9 minus 2 over 7 u raised to the power 7 plus power 5 over 5 plus c. Not forgetting that the negative affects the inside. Alright. So finally we get negative 1 over 9 u raised to the power 9 plus 2 over 7 u raised to the power 7 minus 1 over 5 u raised to the power 5 plus c. But u is equal to cosec x. So negative 1 over 9. We are doing substitution, so do the substitution. Then cosec x over 9 plus 2 over 7 cosec x power 7 minus 1 over 5 cosec to the power 5x plus c. So that is the final answer for that. And that and there. Alright, I would like you to go and try your hands on these questions. You can go and try your hands on integral of 5 over 4. Then we have square root of tan x self square. Self to the power 6x dx. Go and use the same idea to solve it. I would like you to also go and try on. Now, what if it doesn't fit the idea? There are some cases that it will not fit the idea. Make sure that you don't create your own identity, alright? Anyway, let's try on such question and see how we are going to deal about it. Alright, so you try on this one. Alright, let's continue. So what if you have the integral of 1 minus tan square s over sec square s dx? You can see that this doesn't fit the idea. Alright, this doesn't fit the technique. And don't create your own identity. Alright, so let's continue. So in this case, you can see that the integral function here doesn't fit what you know already. So what we have to do is that we have to split this. This is the same as 1 over sec square x minus tan square x over sec square x dx. So we are going to change the tan x and the sec to cos and sine. In fact, anytime that you have such case and you can't do anything about it, that's how we do it. We transform all back to sine and cos, and that's the only thing that is going to help us. Now we know that 1 over sec x is cos x. So here we are going to get cos square x, since here is 1 over sec square minus. Here we know that this we can write it as this tan square x times 1 over sec square x dx. So we get cos square x minus, this is the same as sine square x over cos square x times 1 over sec square is the same as cos square cos square x dx. So with this, you can see clearly that this will take away this, alright? And now here we get cos square x minus, when this square of this is going to be left with sine square x dx. So you can see now that what we have here is resembling a trigonometric identity of a double angle, but cos square x minus sine square x is going to be equal to cos 2x. So since this is the same as cos 2x, by substitution we get cos 2x dx. And to integrate it, we get 1 over 2 sine 2x plus c. So that becomes our final result for such case. You see, it doesn't fit, but we can use our idea in algebra to split this into two and divide by and transform all to sine and cos, and you see that everything will be easy for us. Very good. Very good. So this ends our video and technique for trigonometric integrals. Or is there any? Let me check. Oh. Alright, so I encourage you all to continue solving more questions. You can refer to any, whether your Biju calculus book or Stewart's elementary book, that's your Stewart's calculus book, and also any other reading material that you have. You can refer to that and be solving more questions. Alright, so that is all. Until then, see you for the next video. Bye bye. Please don't forget to go back to YouTube and subscribe to our channel. We have a lot for you. Bye bye. Alright, there was a time also, sorry, I would like to add this in this video. There was a time somebody asked me this question after teaching this topic that, oh, say, what if we have an integral function whereby the angles are not the same? You can see that all that we have looked at it right now is the case where the angles are the same. You can have integral of sine 2x cos 2x. Or integral of sine x cos x. In all that we have looked at it right now, the angles were the same. So what if the angle is not the same? Alright, so what if the angle for sine and cosine is not the same? What if they are not the same? That's what we're going to look at it here. So if you remember from your trigonometric identities, we have the case where sine of the angle here and the sine of the angle here is not the same. If these two meet, then it's the same as this. So if you are to integrate this, you see the m is not the same as the n. So here can be x, here can be 2x. So if it's not the same as this, integrating this, excuse me. Integrating this is the same as integrating what? The right hand side. Integrating this is the same as integrating this. Integrating this is also the same as integrating this. They are all trigonometric identities. Also, this half, you can multiply throughout, you can multiply throughout, you can multiply throughout. So when you do that on this side, then the half of this will come to this side. Alright. So this is all that you know already. So it's very, very necessary for you to know that in case it's not the same. You can't go by the idea that you know already. Alright, let's look at this question. We have sine x The argument here is x. The argument here is 2x. They are not the same. So when such happens, then we have to go for the identity. So we have to go for the identity. So sine cos, sine cos. Okay. So sine cos, and the argument there is x, the argument there is 2x. So it's the same as what we have here. Exactly. So we quote that this inside of this is the same as half sine. Now don't write mx. You know that is what x minus nx, and that's the argument for what? Cos, and that is what? 2x plus sine, that is sine nx. So that is the mx is 4. Okay, so that is x plus 2x. Very good. That is what we have for this. Very good. So we integrate it. So now to integrate it is the same as integrating it. Here we know that the half can come outside. And when the half comes outside, we get sine x minus this, we get negative x plus. It's just simple, okay? It's just that you have to recognize your formula. And then you get 3x. Alright. So when you integrate this, what will you get? You know that when you integrate sine, you get negative cos. Alright, you get negative cos. But the negative here will affect it. So here we will get cos s plus when you integrate sine here, you get negative cos. So here you get negative cos by the constant here, 1/3. Then we get 3x. Alright? Very good. So that is that. And here you add plus c because we are done with integration. So when my half constant is, you get half cos x minus 1/6. That is 2 multiplied 3. Cos 3x. Alright. Plus c. So that's going to be the final answer for that. You see that it's not difficult. Alright. So yeah, I hope your question is also answered because I'm sure you were also thinking of the same thing. That is why I came back to address such case. Very good. Thank you for the next video.